Alright, in this video we're going to talk about the second method for solving systems of equations, which is elimination. So if you forget, the three methods of solving for systems of equations are graphing, elimination, and substitution. We should know graphing by now. Whether you do it manually or whether you do it with graphing software, you're always looking for where they intersect. The second way, which is what we're talking about today, is elimination. And elimination is when you add the two equations together and you design them, you manipulate them, you make it happen to where something gets eliminated. It'll make more sense when you see it. Let's just go ahead and start an example. Alright, so we have a system of equations here. A system of equations is any time that you have two or more equations that you're trying to solve at the same time. And if I drew, let's just say I drew a line here and here. So I broke it down that I have a column for my x's, a column for my y's, and a column for my numbers. And just like with combining like terms, we add. That's exactly what we're going to do here. We're just going to add all of this together. And watch what happens. 3x plus 4x would be 7x. Positive y plus negative y is actually going to give me nothing. Like the positive 1 and the negative 1 will become 0y. And 0y is nothing. So I won't have any y's. And 17 plus 18 is 35. So now I have a very simple equation. I have 7x equals 35. And I divide both sides by 7. And I get that x is 5. Well, now that I know that x is 5, I can plug that back in, and it will help me find what y is. I always tell my students that if, like x is 5, y is 5. Wait, sorry. X is 5. Hold on a minute. So anywhere there's an x in the problem, I can either write an x or I can write a 5 because they're both the same thing. I get to choose which one I pick, and I will choose whatever's best for me at that moment. Just like in a recipe, if it calls for sugar and you're a diabetic, you would use Splenda because Splenda is a replacement for sugar, but it's sugar-free. But they're equal. Technically, you could use either one. So if the recipe has sugar in it and you need to use Splenda, then you just replace it. If the equation has an x in it and if putting a 5 in helps you, then that's what you should do because they're equal. So we're going to use x equals 5 and plug it back into one of the original equations. And it does not matter which one I pick. I always pick whichever one I think is going to be easier for me. And I'm going to guess the top one. I'm going to plug it into this one. And I could have chosen the second one, it won't matter. So I'm going to write it again. And notice that it has an x in it. So just like the recipe calls for sugar, this equation calls for x. But instead of using x, I'm going to use a 5. Because I know that x is 5. One thing that you have to realize is that 3x means multiplication. 3 times x. So when I plug the 5 in, it becomes 3 times 5. And 3 times 5 is 15. So what number plus 15 would give me 17? That's where I'm looking at now. Or I could subtract 15 from both sides. Either way, I'm going to get that y is 2. So I do have my solution. My solution is x equals 5 and y equals 2. And if I wanted to write it as a coordinate point, it would be 5, 2. So let's do another one, and we'll see if a little bit of practice helps. We've already done number 1 here. So let's go ahead and do the riddle part of it. It was 5, 2. So I'm going to go over 5 and up 2, and sure enough, the answer is T. So let's go ahead and do number 2, and we're just going to work through a couple of these until we feel more comfortable. But these are all set up perfectly because you're beginning, and they're all going to eliminate without any work. As we get better at elimination, they'll become more difficult, and we'll have to do more work in each problem. Alright, so here's the problem as it's written, and I'm just going to make my columns to separate my parts, okay? And I'm just going to add them up. The thing that eliminates here this time is the x's. Positive 5x plus negative 5x is going to become 0x, which is nothing. So we're just going to eliminate that. Is going to go to nothing. The y's, they will stay, because 6 plus 2 is just 8. And then I have my equal sign. 13 plus 11 is 24. Hopefully by now you are excellent at one-step equations, two-step equations. This is a very simple one-step equation, so we're going to divide both sides by 8. And 24 divided by 8 is 3. So we have part of the solution. We know that y equals 3. What we don't know is what x is. So this time we're going to plug 3 back in for y, and again it does not matter which equation we pick. So let's look at the equations and see which one we're going to pick. Okay, so we know that y equals 3. So let's look at these and see which one is easiest to plug it into. Probably the top one again because there's no negatives. So I'm going to pick the top one again. If we wanted to, we could pick the bottom one and it would not matter. So 5x plus 6y equals 13. But instead of writing a y, I'm going to write a 3. So I'm going to take out the y, and I'm going to put a 3 in there. And don't forget 6y means 6 times y, so 6 times 3 is 13. So to save space, I'm just going to write 6 times 3 is 18. I'm sorry, I think I said 13. Now, this is a two-step equation, and now I need to solve it. So this is good practice for us because it's been a little while since we've done two-step equations. We're going to subtract 18 first, and these will go away, and we get 5x equals negative 5. 13 minus 18 is negative 5. And then we're going to divide by 5 on both sides, and we get that x is negative 1. So we have our coordinate point. X always comes first, so negative 1, comma, 3. So if we go back to our sheet and we find that coordinate point, negative 1, 3, we'll see what letter is there. Okay, so negative 1 and then up 3. So that was over and then 1, 2, 3. So it's E. So number 2 is E. Let's pick another one. Okay, let's look at number 6. Let's do number 6. Number 6 is a little different. Alright, I'm really glad they have these on there because this is a little bit harder. Notice if I added these right now, let's just go ahead and add them right now. I would get 12x, 20y, and negative 80. Nothing eliminates. this doesn't help me to add these because nothing goes away. I just have bigger numbers now. We have to make it happen for something to go away. Like, it has to be a choice that we do. So what we're going to do is we're going to make either one of these 6's negative, or, yeah, that's what we're going to do, because these aren't even the same number. It's not going to help me there. So I'm either going to make this a positive, this a negative 6, or this a negative 6. And it doesn't really matter which one. Let's review something first, though. If I'm going to distribute a negative, what happens is, technically, it could be a negative 1. You could think of it as a negative 1, or you could just think of it as a negative, or you could even think of it as a minus sign. But no matter what, negatives are the opposite. Negative could be negative, or it could be opposite, and it's interchangeable. So in this case, when you're distributing a negative, you're really finding the opposite of everything in the parentheses. So this was a positive A, and now it'll be a negative A. And this was a positive 4, and now it'll be a negative 4. And this was a negative 2b, and now it'll be a positive 2b. It doesn't change the numbers. If all you do is distribute a negative, it does not change any of the numbers. It only changes their sign. So notice that we don't need it to change the 6's. The 6's are fine. What we need is one of them negative and one of them positive. So now we're just going to pick which one we're going to make negatives. I think it's going to be easier if we make the second, if we distribute a negative here in the second equation, because the numbers are smaller. Not that it matters, really. It really doesn't. So what we're going to do is we're going to go through and we're going to change the sign of everything. So this was a positive, and now it'll be a negative. And this was a negative, and now it'll be a positive. Notice that if I add now, the x's will be eliminated, which is what we need. So we had to distribute a negative. As long as you multiply everything by the same number, you can change any equation. So for example, let's say it was 4x plus y equals 100. If I want to multiply this entire equation by 5, I can. So if I multiply everything by 5, I can totally do that. Nothing changes. I've not done anything undoable. I'll still get the same answers in the equation. So we are multiplying everything by a negative in that second equation. And because we want it to both sides and everything on both sides, it doesn't matter. It doesn't change anything. So if I take a positive 6x plus a negative 6x, they're going to become 0x, which is nothing. 0 cookies means no cookies. 0 x's means no x's. Then if I take 15y minus 5 or 15y plus negative 5, same thing, I'm going to get 10y. And negative 45 plus positive 35 is going to give me negative 10. And you can check all of these on your calculator. Just put them in exactly the way they look. You know, negative 45 plus 35. 15 minus 5. And then we're going to divide by 10 because we're trying to get y by itself. And we get that y equals negative 1. So we know what one of the equations, the solutions are. We know the y, but we still don't know the x. So we have to use the y and plug it back in for the y and define the x. It's kind of hard to say, but it's not that hard to do. Let's just pick one of the equations now so I don't have to rewrite both of them. I think I'm going to pick, I'll pick the top one again. So I'm going to rewrite it. It was 6x plus 15y equals negative 45. And what we know is that y equals -1. So instead of writing a y, I'm going to write a -1. And then we have 6x plus 15 times -1 is -15. I can write it like the way it's written here, or I can write it just -15. And I think that it's easier if you do write it like that. Sometimes it's easier if you do plus a negative, but notice this, plus a negative is the same thing as minus a positive. So you can switch those around and it's fine. So in this case, minus the positive I think is easier. So we're going to use that one. So we're going to add 15 to both sides. These 15s go away. And then we get 6x equals -30. Because -45 plus 15 is -30. Then we're going to divide by 6. And x equals -5. So we have our coordinate point. Our coordinate point, I'm running out of room here, I'm just going to erase some of it. Our coordinate point is -5, -1. And let's go look back on the sheet and find out where that is. So -5, -1. Okay. So if I come over 5 and down 1, it looks like it's h. So I want you to try some. Let's do one more together. Let's do number 8. And then I want you to try some. Maybe we should do 7. We'll do 8. Okay, so this one's kind of all kinds of messed up. We have things everywhere. Notice that if I drew my line, I don't have my equal signs lined up. You know, it would look more like this, and so that's very confusing. We don't want that, so we need to rearrange them so that they're lined up correctly. So I'm going to rewrite this top one. So I have 8x. I'm going to leave some space for my y, and then I'm going to say equals. Okay, so notice that all I've done is I've left space here. Okay, so I'm going to erase this. And what I really need to do is I need to have this 5y over here. If I could get that, then I would have them all lined up. I'd have my x's, I'd have my y's, and I'd have my numbers. So that's what I need to do. So if you remember that trick I told you about when you needed something to move across the equal sign, the only thing that would change would be the sign. So it's a -5y, it's a -5y, -5y, and then all of a sudden we're crossing over the equal sign. Now it's going to be a +5y. And it's not over here anymore because theoretically I picked it up and dragged it across. So now I have what I need. Now if I add all of this up, I'm actually going to, I'm not going to get anything eliminated yet. I need to make one of these negative. So I can either make that one negative or I can make this one negative. And I think I'm going to make the top one. I think I'm going to change it because there's a lot of negatives in that top one. And I prefer to use positives. So if we multiply everything up here by a -1 or distribute a negative, what will happen will be this will be a -8x, this will be a +3y, and this will be a +31. So what we did was we went through and we multiplied that top equation by -1. And now, if I add, then the 8x's will go away. They'll become 0x. Then I get 8y equals 40. I'm going to give myself some more room. So if I divide by 8, I get that y equals 5. So we're halfway done. Now we have to use that to find out what x would be. Okay, so what we're going to do is, what we know is that y equals 5. Right? Okay, yeah. So instead of putting a y, we're going to put a 5. Just like sugar and Splenda. I get to pick. Either I can keep it as a y, or I can change it to a 5, because they're both equal. This is 5 times 5, which is 25. And then I got 9 minus 25. 9 minus 25 would be negative 16. Had to think about that. So 8x equals negative 16. Then we divide by 8, both sides, and we get that x is negative 2. So the coordinate point, we have both parts now. X always comes first, so negative 2, comma 5. Now if I go back to our original problem, negative 2, comma 5 would be C. So this answer would be C. So I want you to work on some. Make sure you raise your hand if you have questions. Watch the video again if you need to take notes, better notes. If I go too fast, you can always pause. And these are actually pretty fun to do once you get used to them.